Hi everybody, welcome back. Here are the screencast notes for the light article. I believe it started on page 17 in the packet, so you can follow along and highlight or add to your notes. So first I started with a picture of the electromagnetic spectrum. What I want you to notice though is this electromagnetic spectrum is arranged highest to lowest frequency. A lot of times you'll see it lowest to highest. So when you look at a chart like this, it's really important to remember that when you see the waves close together like this is the high energy and spread out is the low energy. And they list all of the types of radiation or electromagnetic energy that there is. And we'll go through each section. So we start with our lowest energy, which are radio waves. They're all around us. They're produced by stars and radio stations. We can use them for cooking. And they have the longest wavelength. So if you're worried about microwaves leaking out of your microwave and hitting you, they do hit you, but they bounce off. They don't have a lot of energy. They can't penetrate so much our skin. Then we go to infrared waves. These are heat lights. You might see them in a tank for lizards. You feel it when it's on. This is the same, this is what night vision goggles pick up. So they see the heat waves that are being given off. And the word infra, the prefix infra, means below. Then we have the visible light, and that's what we see. It's white light, but it's actually a combination of the colors of red, orange, yellow, green, blue, indigo, which is kind of like a purple, and violet. And we use the mnemonic Roy G. Biv to remember the order of the light radiation. A white light is a combination of all the light colors, and when you have no light, it's black, and it's the absence of all colors. Ultraviolet light is ultra, above visible light. There's UVA and UVB. That's a substance you put on your body and it blocks those. We do have UV pens that we'll be playing with in class. We do need some UV light, and that's the same kind of light that we use in our goggles cabinets. It is harmful to the outer layers of our skin in high doses, and it's definitely harmful to bacteria and viruses, which is why we put the goggles in the cabinet and turn on UV light and kill any little buggies that might be on there. A ray is just another name for a light wave. So X-rays are the next classification of light, and these light waves have so much energy they pass through most solids except for lead. And we use them in security, we use them in medicine instead of cutting open. And then we go to gamma rays. And if you don't mind, I'm going to flip back for a minute. What I tried to do was put the titles of the units in order of Roy G. Biv. Red, orange, yellow, green, blue. Microsoft says this is the color indigo. I don't know how true that is. So here is the color indigo. Oh. And these are gamma rays. This is the highest energy, the shortest wavelength. We use them in nuclear medicine to help destroy tumorous cells in very, very small amounts. This is the energy that's released from atomic bombs. It's just ridiculously high energy. Now we have the properties of light. Light does travel in a straight line, but remember it's a wave traveling in that line. And these rays travel out from their source in all directions. So if I have a radio tower sending out a radio wave, it's sending that radio signal out in every single direction. It's a lot faster than sound, and they don't need a medium. So light waves can travel through outer space. These light waves have a finite speed, and the speed of light is considered a constant, and you'll see it in equations labeled C. And light does travel a little slower when it passes through different substances with different densities. So light travels slower through solids and liquids. Alrighty, and then there's the summary. Now that was the first part of the article. I have another picture of the electromagnetic spectrum. We have this on a poster at school, but again, this one starts at very low frequency to very high frequency. And this one groups all radio waves together. So a lot of times you see microwaves put in with radio waves. Microwaves and radar are the highest energy radio waves, so sometimes they're pulled out. Now, when visible light hits a surface, one of three things can happen. The light can either be reflected, and there's two kinds of reflection. Either reflection that's called specular, where you can see an image in it. This sometimes happens in glass or water or a mirror. Or it can be diffusely reflected, where you don't see an image formed from it. And this reflected light is responsible for objects looking a particular color. So if I happen to have a red shirt on, it looks red because all the frequencies of light that are hitting it are absorbed except for red, which is reflected. All right, the next thing that can happen is light can be transmitted. And light can be transmitted in two ways. Uniformly and evenly, such as through a clear windshield, which we would call transparent because it's really easy for light to pass through it. Or translucent, it's over here. This is where light can pass through, but it gets scattered as it passes through. So you can kind of see through it, but kind of not. That's what we call translucent. Or the light can't pass through at all. We call that opaque, and that's like a brick wall. Light does bend as it passes through these substances, and we'll talk a little bit more about that in the next few days. All right, and finally, when light hits a surface, it could be absorbed. Black absorbs all frequencies of light. So if I had a black object and shined white light on it, the light would hit it, be absorbed, and stay there. But you guys know this and you've experienced it. If you wear a black t-shirt out in the summer and the sunlight hits you, the black t-shirt gets really hot because it's absorbing all that energy. Alrighty, we'll be going over pages 23 and 24 in class, but this is information that all came from that article that was in your packet.